This is sections 1.3 and 1.4. It's all about lines. The book has a reason for separating the sections. It has to do with looking at lines not as functions and also looking at them as functions. Remember, all lines except the vertical line do represent a function. So, slope. Definition. Let P1 with coordinates x1, y1 and P2 with coordinates x2, y2 be 2 points on a non-vertical line. Then the slope of the line, and this is denoted by the letter m, little m is always used for slope, is given by m equals y2 minus y1 over x2 minus x1. The common thing that goes wrong is students get it upside down. The y's are in the numerator, the x's are in the denominator. The slope is supposed to measure how steep the line is. The larger the slope in absolute value, the steeper the line. Okay, slope is also called change in y over change in x, which is also rise over run. Remember, the rise is the y direction, the run is the x direction. So change in y over change in x, or rise over 1. The slope of a vertical line is undefined or does not exist. So if you're looking at a vertical line and you're asked for slope, say does not exist or undefined. You can also use capital D-N-E for does not exist. So warning. Number 1, do not say no slope when you mean the slope does not exist. If the slope does not exist, then say slope does not exist. Or you could also say slope is undefined, or you can write D-N-E. Number 2, do not say no slope when you mean the slope is equal to 0. If the slope is equal to 0, then you should say m equals 0 or slope equals 0. Remember, little m is always slope. Number 3, excuse me, if you write no slope as an answer, no credit will be awarded. So that means you've missed the problem if you ever write no slope. Remember, if the slope does not exist, say does not exist. That's the vertical line. If the slope is 0, write down a 0. That's actually the horizontal line. So some notes about this. Number 1, the slope of a vertical line does not exist or is undefined. All other lines, including horizontal lines, have a slope. Remember, slope is just a number. Number 3, typically slope is a fraction. Because remember, it's change in y over change in x. It's rise over run. That's a fraction. Number 4, when slope is a fraction, it should reduce just like all fractions should be reduced. Okay, always reduce fractions. We do not normally use mixed numbers and decimals for slope. In certain applications, we do, meaning word problems applications. But when there is no special application, we leave the slope as a fraction, even if it is an improper fraction. Number 6, slope is a measure of how steep a line is. Number 7, a positive slope means the line is going uphill as we read from left to right. Remember, that is how we read, from left to right. So positive slope, you're going uphill. A negative slope means the slope is going downhill as we read from left to right. A slope of 0 means the line is neither going uphill or downhill as we read from left to right. The line is horizontal. All horizontal lines have m equals 0. Number 10, a slope that does not exist means a vertical line. And also remember, vertical lines were not functions. So it's like all linear functions, the slope does exist. Let's have a picture of these things. So here's our pictures. This one, the slope is positive. I'm going uphill as I read from left to right. In this picture, the slope is negative, so as I read from left to right, I'm going downhill. In this picture, the slope is equal to 0, horizontal line. In this picture, the slope does not exist, vertical line. Remember, this one is not a function. All of the others, the other 3, they are functions. Try some examples of finding slope. Now remember, slope is a fraction, reduce the fractions. So find the slope of the line that passes through each pair of points. Simplify your answers. Do not use mixed numbers and decimals in your answers. Okay, remember, the simplify means reduce your fractions. So here's our first example. My points were negative 4, 6 and negative 9, 3. Now, just like when we're doing distance formula, midpoint formula, they don't know who's first or second. Just remember, it's always an x and a y. So for our solution, I let x1, y1 be negative 4, 6. I let x2, y2 be negative 9, 3. And remember, m is equal to y2 minus y1 over x2 minus x1. Plug in the numbers. So I'll have 3 minus 6 over negative 9 minus negative 4. Do the arithmetic. This is negative 3 over negative 5. Negative over negative is positive. So it's 3/5. The slope is 3/5. Now what does this really mean? This means that every time you move 5 units to the right, the denominator 5 units to the right, then you move up 3 units in order to stay on the line. We will always go from left to right. So you always go right, whatever the denominator is, and then you move up or down, whatever the numerator is. If the numerator is positive, you go up. If the slope is negative, you go down. Remember, we will always go to the right, and then go up for positive slope, down for negative slope. So go up or down, whatever the numerator is. Number 2, my points are 6, negative 7, and 6, 4. So again, I will let x1, y1 be 6, negative 7, and x2, y2 will be 6, 4. Our slope, remember, m is y2 minus y1 over x2 minus x1. Fill in the numbers. So y2 minus y1, I'll have 4 minus negative 7. My denominator, 6 minus 6. So I end up with 11 over 0. We're not allowed to have 0 in the denominator. So this means the slope is undefined, or the slope does not exist. Okay? It's a vertical line. If you actually plotted those 2 points, you would see that it is a vertical line. For number 3, my points are negative 3, 4, and negative 11, 4. Okay, once again, I'm going to let x1, y1 be the first point, so x1, y1 is negative 3, 4, and x2, y2 is negative 11, 4. Again, our slope, m is y2 minus y1 over x2 minus x1. Fill in the numbers, so I'll have 4 minus 4 over negative 11 minus negative 3. 4 minus 4 is 0. Negative 11 minus negative 3 is negative 8. 0 over negative 8 is equal to 0. So the slope is 0. This is in fact a horizontal line. If you plotted the points, you would actually see that it is a horizontal line. Again, remember, with slope, always reduce your fractions. 0 in the denominator means slope does not exist. 0 in the numerator means slope is 0. Equations of lines and linear functions. Remember, all non-vertical lines are in fact functions. So we will be looking at 4 different forms for the equation of a line. In all but one of the forms, the name of the form tells you what you need to know in order to use it. At this point in our mathematics education, we're not really interested in where the forms came from. We're more interested in how to use them. But in case you are wondering, they all somehow came from the definition of slope. Please learn the different names and their forms as we present them in this class. You are responsible for knowing them as they are defined in this class. One of them that has slightly different forms but with the same name. So please learn them as we present them here. So the first one, 2-point form. Okay, remember 2 points will draw the line, so 2 points should give you the equation for the line. Now as the name implies, what are you given? You're given 2 points. You're given P1 with coordinates x1, y1, and P2 with coordinates x2. That's what's given to you. What does the form look like? Okay, the form looks like y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. Okay, again, the little subscripts means you're going to be told the values of those numbers. The guys without the subscripts, that's allowed to be any point, and this is the equation that must be satisfied in order for that point to stay on the line. Students usually don't like this form because of this awful looking fraction. But if you look at that fraction, that's really slope. So the 2-point form is going to make you calculate the slope. Because if you're given 2 points, you can find slope. We just looked at that. Now sometimes you're lucky and you don't have to calculate slope. It's given to you. So our second form, point slope form. Okay, so as the name implies, what are you given? You're given a point, P1 with coordinates x1, y1, and the slope m. So you don't have to calculate the slope, you just replace that fraction in the previous form with m. So the form looks like y minus y1 is equal to m times x minus x1. Now again, remember, the x1, y1 is given to you. The xy is supposed to be the coordinates of a point, and this is the equation that those coordinates must satisfy in order to stay on the line. Our next form is actually a special case of this one. You're actually given a special point to work with. So, slope-intercept form. Okay, slope-intercept form, what are you given? You're given the slope m and the y-intercept 0b. So notice, this is a special point that's given to you. The form is y equals mx plus b. This is the form that most students are used to seeing. Some notes on this. Okay. Number 1, slope-intercept form is solved for y. It says y equal. Notice if you're trying to graph it on your calculator, that's the form that you need. You need y equals. When solved for y, the coefficient of x is the slope. Okay? That's why we use m. So it has to be solved for y in order for the coefficient of x to be equal to the slope. When solved for y, the constant term, so the plus b part, is the y-coordinate of the y-intercept. Remember, the x-coordinate of the y-intercept is 0. There are other uses for the slope-intercept form. So other uses for y equal mx plus b. Now we say we use what's given to you is you're given the slope and the y-intercept. One of the other uses is we use it to find the slope and the y-intercept. So if we're given one of the other forms for the equation of a line, we put it in y-intercept, slope-intercept form in order to get the slope and the y-intercept. It's also the preferred form of answers when finding equations for lines. This is because every line has a unique slope-intercept form. None of the forms that we look at are unique for a given line. Okay? So this is the only one that's unique. None of the other forms that we look at are actually unique. There is another form of a line that's unique, but we actually don't look at it. Most algebra classes never do look at it. It's usually given as a problem in the textbook. Number 3, it is set up for a linear function. As a function, y equals mx plus b becomes f of x equals mx plus b. General form. Okay? General form. What are you given? You're given nothing. So it's usually the problem that is given to you. The form, what does it look like? It looks like capital AX plus capital BY equals C. Notice it has the variables on the left and a constant on the right. Where? The first condition, A, B, and C are integers. So notice it doesn't allow fractions. In a way, it's kind of nice. It's tough dealing with fractions. Second condition, not both A and B are 0. Notice, if both A and B are 0, you'd have 0 plus 0 equals C. That forces C to be 0. So it's okay if one of A and B is 0, but they can't both be 0. And the third condition, A is greater than or equal to 0. The coefficient of x can't be negative. It's okay if the coefficient of y is, but the coefficient of x is not allowed to be negative. This is usually the condition that students forget about. Now personally, I like the general form because the coefficients aren't allowed to be integers, or excuse me, are not allowed to be fractions. They have to be integers. Note, the general form of a line is sometimes called the standard form for the equation of a line. That's because a lot of different things in mathematics have standard forms, and we would like a line to have one too, so we usually pick on the general form to also be called the standard form. We will call it the general form. And then the general form puts the variables on the left. X is first, it's alphabetical order, and the constant term is on the right. So before doing examples, we will present all the facts about lines that we will use in this course. And then we're just going to have a bunch of examples. So when doing homework problems and test problems, read directions very carefully as to what form your final answer should take. Now, for homework problems, it's also true for test problems. Since there is no partial credit, using the wrong form in your answer will result in the entire problem being marked wrong. Similarly on a test, using the wrong form will result in the answer being marked wrong, and also on quizzes. Okay? If you use the wrong form anywhere, the answer will be marked wrong, because part of the question is, do you understand what the form is? And if you don't write the correct form, then that's saying you don't know what the form is. Most of the problems require that your final answer be in either slope-intercept form, the y equals mx plus b, general form, ax plus by equals c with no fractions, and a not negative, or in linear function form, which would be f of x equals mx plus b. Now if you're asked to write a function, write f of x, don't write y. So let's get on with some of the more fun facts to know and tell about lines. So remember, if you have to explain what is wrong with your answer, it is still wrong. Okay, telling me what you did wrong and telling me what would be correct doesn't make your answer correct. Because if you meant to do it, you should have done it. Vertical and horizontal lines. Remember, the vertical lines aren't function. The horizontal lines are. So these are kind of like special types of lines. Let's first look at the vertical lines. The properties. Okay, my red line is vertical. Okay, the standy uppies. The properties of it. The slope does not exist. Okay? Slope does not exist for a vertical line. The y-intercept does not exist. Notice this thing is not crossing the y-axis. Now the other, if it actually were the y-axis, then your y-intercept would have its y-coordinate, all real numbers. And number 3, the simplest form of the equation is x equals a number. Okay, that's the simplest form. Notice this is general form. Okay, so x equal a number is the simplest form for the equation of vertical line. Notice it's missing the variable y, and y is the vertical axis. Let's look at horizontal lines. Okay, well, whoops, nope, the y-axis is a vertical line. It has all real numbers as the y-coordinate of its y-intercept. The equation of the y-axis is x equals 0. Okay, now let's look at horizontal lines. Okay, my red line is the horizontal line. Okay, the lay downies, the properties. The slope is m equals 0. Okay, it's not rising, it's not falling. The x-intercept does not exist, unless of course it's the x-axis. Number 3, the simplest form of the equation is y equals a number. Okay, y equals a number is both general form and it's also slope-intercept form. But notice the variable x is missing, and x is the horizontal axis. Okay, now again, the x-axis is a horizontal line. It has all real numbers as the x-coordinate of its x-intercept. The equation of the x-axis is y equals 0. So that's our vertical and horizontal line. Now take a look at parallel and perpendicular lines. Okay, parallel and perpendicular lines. Let's do the parallel lines first. Okay, my red line and my blue line are parallel. Notice they slant the same way. That would mean they have the same slope. So the properties. Parallel lines are lines that are in the same plane and that never touch. Two lines are parallel if and only if they have the same slopes but different y-intercepts. If they have the same slopes and the same y-intercepts, it's the same line twice, and they would be called coincident lines. Remember, we looked at 4 different forms for the equation of a line, so it could be possible that you have 2 equations for the same line and you just didn't know it. Different vertical lines are parallel to each other. We have to take care of that separately because remember, vertical lines, the slope doesn't exist. So just because 2 things don't exist, don't mean they're equal to each other. Let's now take a look at perpendicular lines. Okay, so perpendicular lines. Okay, my red line and my blue line are supposed to be perpendicular. That means they meet at a right angle. And notice they do in fact intersect. They have to intersect. So perpendicular lines are lines that intersect at right angles to each other. Okay, they do have to intersect. 2 lines are perpendicular if only if their slopes are negative reciprocals of each other. So the negative reciprocal of A over B is negative B over A. Okay, this property is sometimes stated that they're perpendicular if and only if the products of their slopes is equal to negative 1. So if you multiply the 2 slopes and get negative 1, that's perpendicular. Another way of looking at it is if you can go from one to the other by flipping it over and changing its sign, that's perpendicular. The third thing is horizontal and vertical lines are perpendicular to each other. The classic example, the x and y axes. Let's try some examples of determining whether or not a pair of lines are parallel, perpendicular, neither, or both. So, oops, what am I doing first? I'm finding the slope and y-intercept of each line. Simplify your answer. Do not use mixed number decimals in your answers. Write the y-intercepts as points. This would actually be a 2-point problem if we're on a homework assignment because you get 1 point for the y-intercept and 1 point for the slope. So here's our first one. I got 3x plus 2y equals 18. Remember, we're looking for slope and y-intercept. In order to find slope and y-intercept, we have to find slope-intercept form. Okay, we have to find slope-intercept form. That means solve for y. Okay, you want to get y by itself. You want to get y equals mx plus b. So we're starting off with 3x plus 2y equals 18. Okay, move the 3x to the other side, and we're right at first. Remember, it's mx plus b, not b plus mx. So I get 2y is equal to negative 3x plus 18. Remember, I want y by itself, so divide everybody by 2. So I'll have y is equal to negative 3 halves x plus 9. So again, I divided everybody by 2. It now is in the form y equal mx plus b. Remember, when you have y equals, the coefficient of x is the slope. So slope is negative 3 halves, and this is the y coordinate of the y-intercept, so as a point, it's 0, 9. So that's all we're doing. We're solving for y. See number 2. I have 7y equals 14. So again, solve for y. So starting with 7y equals 14, just divide by 7. So y is 2. Okay, notice there is no x here. So in my y equals mx plus b, what made x go away was I must have multiplied it by 0, because 0x would have been 0. So my slope is 0. This is the b, so my y-intercept as a point is 0, 2. So when there is no x term, the slope is 0. Number 3, I have 5x equals 20. 5x equals 20. Again, I want to solve for y. Well, this will be a challenge. There is no y. We can solve for x to get x equals 4, but I cannot get y equals. So notice the thing that I need to do in order to answer the question cannot be done. That means the slope does not exist and the y-intercept does not exist. This is a vertical line. So when you cannot solve for y, when there is no y in the equation, slope does not exist, y-intercept does not exist. Okay, now we'll take a look at determining parallel, perpendicular, or neither. So again, warning, do not write no solution. This is the solution. Okay, so some examples. Determine whether each pair of lines is parallel, perpendicular, or neither. And sometimes just to fake you out, I do like to put or both. Think about it. It can't ever be both. So this is kind of like multiple choice. Parallel, perpendicular, or neither. So here are my two lines. I'm calling that L1 and L2. You know, line 1, line 2. So L1 is 2x minus 3y equals 9. L2 is 3x plus 2y equals 18. Remember, I need to find the slopes. Parallel and perpendicular are making statements about slope. So we must find the slope of each line. Remember, that means we have to put each line in slope-intercept form. So we have to solve each equation for y. So for each equation, I want to get a y equals. Okay, starting with L1, I've got 2x minus 3y equals 9. Okay, subtract 2x. I'll have negative 3y is equal to negative 2x plus 9. Divide everybody by negative 3. No, minus over minus will be plus. So I'll have y is equal to 2/3 x minus 3. Okay, let's call its slope m1 since it's the first line. So my m1 is 2/3. Okay, m1 is 2/3. Do the same thing for L2. I got 3x plus 2y equals 18. Again, I want to get y by itself. Subtract 3x. So I have 2y is equal to negative 3x plus 9. Divide everybody by 2. So y is equal to negative 3 halves x plus 9. So my m2 is negative 3 halves. Okay, now, they're not equal, so they can't be parallel. Now, can I go from m1 to m2 by flipping it over and changing its sign? Yes. Another way of looking at it is, if you multiply 2/3 times negative 3 halves, do you get negative 1? Yes. That's perpendicular. So we can get from m1 to m2 by flipping it over and changing its sign. That means the lines are perpendicular. Okay? The lines are perpendicular. Example number 2. I have x equals 12 and x equals negative 4. Okay, x equals 12 and x equals negative 4. Okay, this is two vertical lines. Remember, vertical lines are all parallel to each other. Okay? Two vertical lines are parallel to each other. Number 3. My L1 is 4x minus 3y equals 19. My L2 is 8x minus 6y equals 12. Okay, I'm back to solving for y. So solve each equation for y. Okay, for L1, I'm starting with 4x minus 3y equals 19. Okay, subtract 4x. You'll have negative 3y is equal to negative 4x plus 19. Divide everybody by negative 3. Remember, I want y equals. So y equals 4/3 x minus 19/3. This slope is 4/3. Do the second line, L2. I'm starting with 8x minus 6y equals 12. Okay, subtract the 8x. So I'll have negative 6y is equal to negative 8x plus 12. Divide everybody by negative 6. So I have y equals 8 6x minus 2. 8 over 6 reduces to 4/3. So my m2 is 4/3. They do have the same slope. Now, you also have to verify that they also have different y-intercepts. So, same slopes, but different y-intercepts. They're parallel. Number 4. My L1 is y equals 3x plus 7. Okay, that's already in slope-intercept form. My L2 is negative 3x minus y equals 11. So again, we have to solve each equation for y. We only have to do it to L2. L1 is already solved for y. So we're just going to observe that m1 is 3, right? Y equals mx plus b, so my slope 1 is 3. Now let's look at L2. I'm starting with negative 3x minus y equals 11. Add 3x. So I've got negative y equals 3x plus 11. Remember, I want y, not negative y. So change all the signs. We're really multiplying by negative 1, or if you prefer, we're dividing by negative 1. So I'll have y equals negative 3x minus 11. This slope is negative 3. Well, they're clearly not the same. Now, if I multiply the two slopes, 3 times negative 3, I get negative 9. That's not perpendicular. These lines are neither. So they're neither parallel nor perpendicular. Neither. Most pairs of lines are neither. Remember, if they're perpendicular, the products of the two slopes has to equal negative 1. Let's try finding equations of lines. Now, find an equation of the line that satisfies the stated conditions. Simplify your answers. Do not use mixed number decimals in your answers. In Part A, express your answer in general form. In Part B, express your answer in slope-intercept form, if possible. Now, in general, for a homework problem or a test problem, you're not going to do both A and B. You'll do one or the other. I'm doing both in the examples, so that way you'll see how to write your answer in general form and also how to write your answer in slope-intercept form. So, remember, on a homework problem, test problem, quiz problem, it would be one or the other, not both. So here's our first one. It has slope 2/3 and y-intercept 0, negative 5. Okay, slope 2/3 and y-intercept 0, negative 5. It looks like I'm given m and b. So we're given m is 2/3 and b equals negative 5. Notice this one is set up for slope-intercept form. So I can actually answer part B first. So we'll start with slope-intercept form. Y equals mx plus b. Just fill in the numbers. So y equals 2/3 x plus negative 5. And of course, to simplify, plus minus is minus. So y equals 2/3 x minus 5. That's the answer for part B. And part B was the slope-intercept form. Can you do part A to get general form? Let me just keep working on this. So we clear fractions for part A. Remember, in general form, not allowed fractions. So multiply everybody by 3. We'll have 3y is equal to 2x minus 15. And remember, general form wants both variables on the left, and it wants x first. So subtract 2x. I'll have negative 2x plus 3y equals negative 15. Okay, getting all the variables on the left. Now remember, there was one other requirement for general form. The coefficient of x could not be negative, and it is. So change all the signs. So again, we're multiplying by negative 1 or dividing by negative 1. So I'll end up with 2x minus 3y equals 15. So that's getting my coefficient of x, my a, greater than equal to 0. That's the answer to B. Remember, back up here we found a. No, this is a, that's B. Getting it backwards. So there's the answer to A, 2x minus 3 equals 15. There's the answer to B, y equals 2/3 x minus 5. Now again, I really do prefer general form. It has no fractions. It looks a lot cleaner without fractions. Number 2. It passes through the points negative 3, 5, and 6, 7. Okay, so it passes through the points negative 3, 5, and 6, 7. Okay, you're given 2 points. We will start with 2-point form. Remember, 2-point form is y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. That's the 2-point form. Okay, I'm going to let x1, y1 be negative 3, 5, and x2, y2 be 6, 7. So now we just start plugging in the numbers. So I'll have y minus 5 is equal to 7 minus 5 over 6 minus negative 3 times x minus negative 3. Now again, be very careful. Make sure you put the right numbers in the correct location. Now let's start doing some simplification. Okay, minus minus will be plus. 7 minus 5 is 2, and 6 minus negative 3 is 9. So I have y minus 5 is equal to 2/9 times x plus 3. If I do the problem in order, part A was to get the general form. So remember, general form did not allow fractions. So if I'm going to do part A first, I'm going to multiply everything by 9 to get rid of the fraction. Now remember, when you're clearing of fractions, don't go inside the parentheses. So clearing of fractions, I'm going to get 9y minus 45 is equal to 2 times x plus 3. Multiply everybody by 9, except don't go inside the parentheses. Okay, now I have to distribute the 2. 9y minus 45 is equal to 2x plus 6. And again, remember, we're working on general form, part A. General form says variables to the left, numbers to the right, and x comes first. So subtract 2x, add 45. So I'll have negative 2x plus 9y is equal to 51. And remember, the third requirement for general form, the coefficient of x had to be positive. Change all the signs. So 2x minus 9y is equal to negative 51. That's the answer to part A. Okay? That's the general form. Now, if we're going to get slope-intercept form, part B, I'm just going to pick up where we left off here. So for part B, I'm going to solve for y. Okay, remember, we left off with 2x minus 9y equals negative 51. So remember, I want y by itself. Subtract the 2x. Remember, it goes first. It's mx plus b, not b plus mx. So I have negative 9y is equal to negative 2x minus 51. Divide everybody by negative 9. Okay, so I'll have y is equal to 2 9ths x plus 51 over 9. Okay, 51 over 9 actually will reduce. You can divide both top and bottom by 3. So I have y is equal to 2 9ths x plus 17 thirds. That's the answer to part B. That's your slope-intercept form. So putting them back together, general form, slope-intercept form. Again, I still like the general form better. It has no fractions. It just looks a whole lot better. Number 3. It passes through the point 7, negative 4 with slope negative 3. Okay, I've given you a nice slope. I've given you an integer. But notice, you're given a point and a slope. So we're going to start off with point slope form. So my x1, y1 is 7, negative 4, and my m is negative 3. So my point slope form, remember, is y minus y1 is equal to m times x minus x1. That's your point slope form. You have to learn the forms. Okay, fill in the numbers. So I have y minus negative 4 is equal to negative 3 times x minus 7. Let's do some work on this. Minus minus is plus, and let's distribute the negative 3. So y plus 4 is equal to negative 3x plus 21. Again, if we do it in order, part A was general form. Variables to the left, numbers to the right, and x comes first. So add 3x, subtract 4. So 3x plus y is equal to 17. There's part A. If I were going to do part B, I'll just pick up where I left off, and notice I'm going to move the 3x back. So for part B, solve for y. Picking it up with 3x plus y equals 17, just subtract the 3x. And remember, it goes before the 17. It's mx plus b, not b plus mx. So y is equal to negative 3x plus 17. There's part B. Again, let's put them back together. So part A, 3x plus y equals 17. Part B, y equals negative 3x plus 17. Let's try it. It passes through the point, negative 2, 4, and is parallel to the line 2x plus 5y equals 10. Okay, I'm given a point. I'm given x1, y1. So my x1, y1 is negative 2, 4. Okay, now remember, parallel and perpendicular are making statements about slope. To be parallel to this line, it has to have the same slope as that line. So we must find the slope of the given line. We have to find the slope of 2x plus 5y equals 10. What does that mean? Solve its equation for y. So I've got 2x plus 5y equals 10. Okay, subtract the 2x. So 5y is equal to negative 2x plus 10. Divide it all by 5. So y is equal to negative 2/5 x plus 2. The slope of the given line is negative 2/5. For parallel, we need the same slope. If we were doing perpendicular, we would flip it over and change the sign. So we need m to be negative 2/5. So here's my point. Here's my slope. Point slope form. Y minus y1 is equal to m times x minus x1. Fill in the numbers. So y minus 4 is equal to negative 2/5 times x minus negative 2. Again, that's where we left off before. Now let's do some simplifying here. The minus minus is plus. So So y minus 4 is equal to negative 2. Oh, I cleared the fractions as well because I'm doing part A first. So I multiplied everything outside parentheses by 5. That gave me 5y minus 20 is equal to negative 2 times x plus 2. Again, minus minus is plus. Clearing the fractions, multiply by the 5. Distribute the negative 2. 5y minus 20 is equal to negative 2x minus 4. Again, remember, general form, part A, variables are both to the left, numbers to the right. Add 2x, add 20. 2x plus 5y is equal to 16. That's part A. To do part B, just pick up where we left off. Take this equation and solve for y. So subtract 2x. So 5y is equal to negative 2x plus 16. Again, write it that way. Don't write 16 minus 2x. It's mx plus b, not b plus mx. Divide everybody by 5. So y is equal to negative 2/5 x plus 16 over 5. That's the answer to part B. Remember, back up here was part A. So putting them back together. 2x plus 5y equals 16. And for part B, y is equal to negative 2/5 x plus 16/5. Let's go ahead and do perpendicular. Let's go ahead and make our second example of perpendicular one. So for number 5, it passes through the origin, so there's your point, and it's perpendicular to the line 4x plus 3y equals 21. Okay, now remember, for perpendicular, they have to have slopes which are negative reciprocals. Now, our origin is x1, y1. The coordinates of the origin are 0, 0. So I've got an incredibly easy x1, y1. That's the reason this one's going to be a lot easier than the previous one, because I have a really good x1, y1. So to find perpendicular or parallel, remember, you got to do the slope of the given line. So that means I have to solve its equation for y. So we start with 4x plus 3y equals 21. Subtract 4x. So y is equal to negative 3y is equal to negative 4x plus 21. Divide it all by 3. So y is equal to negative 4/3 x plus 7. Okay, this line has slope negative 4/3. Remember, for perpendicular, flip it over and change the sign. So we need m to be 3/4. Okay, so here's my slope and here's the point. So I've got a point and a slope. Point slope form again, which is y minus y1 is equal to m times x minus x1. And again, we've got an incredibly easy x1, y1. Fill in the numbers. So y minus 0 is equal to 3/4 times x minus 0. Okay, y minus 0 is y, x minus 0 is x. So I got y equals 3/4 x. That's part B. Okay, that's part B right away. So to get part A, I just keep working on this. Remember, no fractions. So clear fractions, multiply by 4. 4y is equal to 3x. Now remember, general form wants the variables on the left with x first and the constants on the right. Notice, the constant is 0. So subtracting 3x, I get negative 3x plus 4y is equal to 0. I'm not allowed to have a negative coefficient on x in general form, so change all the signs. So 3x minus 4y is equal to 0. That's part A. So part A, answer to part B. So for part A, 3x minus 4 equals 0, and for part B, y is equal to 3/4 x. Number 6, I want a vertical line through the point negative 411. Okay, a vertical line through the point negative 411. Okay, recall that a vertical line is x equal a number. Okay, a vertical line is x equal a number. Now, if I'm going to pass through the point negative 411, that number has to be negative 4. Otherwise, it has no hopes of passing through negative 411. So the equation is x equal negative 4. Okay, notice that's the general form. X equal negative 4. Remember, for slope-intercept form, I'm supposed to solve this for y. There is no y. So there is no slope-intercept form. So for part B, we're going to solve for y. Can't be done. So part B has no solution. Okay, this is a vertical line. So part A is x equal negative 4. Part B is no solution. There's no y to solve for. Let's see, for the sake of completeness, let's do a horizontal line. So for number 7, I want a horizontal line through the point 310. Okay, horizontal line through the point 310. Okay, a horizontal line, the simplest form of the equation is y equal a number. Okay, y equal a number. Now, if I'm going to pass through the point 310, that number has to be 10. So I'm going to get y equals 10. Okay, that's part B. It's also part A. Okay, so it's also part A. It's both of them. So I have y equals 10, y equals 10 for both answers. Now let's go ahead and make our life complete by doing word problems. Okay, word problems. Okay, our line word problems fall under two very broad categories, and they are very broad. Those that involve time and those that do not involve time. Okay, both categories usually make you start with two-point form. They do. I don't think I have a single one where you don't start with two-point form. Both categories will usually require to use variables other than x and y. You need to make the transition between the new variables and x and y. Okay, typically with the ones that involve time, and this is the reason it's divided this way, time and not time, is that time is usually the letter T for time, and T corresponds to x. So that means the other variable in the time problems will be the y. It's kind of like with x and y, x is called the independent variable, y is the dependent variable. In time, time is independent because you can't control it. I mean, imagine if we could control time. So typically, for the problems that involve time, t is x and t1 is 0. Okay? If you were not specifically given that t1 is 0, it is usually made to be 0 by saying something like, let t equal 0 correspond to 1998. Then t would be the years since 1998. So that's another reason why we divide it between those that involve time and those that do not. Let's try some examples. Number 1. The value v of a car is a linear function of time t. When new, the car cost $28,000. 3 years later, the car had a value of $19,000. In part A, express the value v of the car as a function of t, where t equals years since purchase. And in part B, what is the value of the car 5 years after it has been purchased? Notice the answer for part B, after I get the answer to part A, I'm just going to plug in t as 5. Okay, for part A, the question itself and this very first sentence in the problem, they're basically telling you, okay, v is a linear function of time t. That's saying v equals mt plus b. That's what it's saying. So for our solutions, the first sentence is saying v equals mt plus b. Value is a linear function of time t. So y equals mx plus b, compared to the v equals mt plus b, xy becomes tv. Okay? Time is the x, value has to be the y. Now, if you recall from the problem, we were given two values and two times. So from the problem, T1 V1 was 28,000. You know, when new, it was purchased for 28,000. Then for time t, 3 years later, it was worth 19,000. Now, if I write down my two-point form using the t's and the v's, remember t is x, v is y, I'll have v minus v1 is equal to v2 minus v1 over t2 minus t1 times t minus t1. Okay, I've tried to rig it so that the numbers will come out nice. Hey, plug in the numbers now. So I'll have v minus 28,000 is equal to 19,000 minus 28,000 over 3 minus 0 times t minus 0. Okay. Again, be very careful. Make sure you plug the correct numbers in the correct location. Okay, t minus 0 is going to be t. 3 minus 0 is going to be 3. 19,000 minus 28,000 is going to be negative 9,000. This will reduce, right? Negative 9,000 over 3,000 is negative 3,000. And then to solve it for v, just add 28,000. There's the answer to part A. V is equal to negative 3,000t plus 28,000. Notice, what we would call the, quote, v-intercept is the value of the car when new. The slope of negative 3,000 says that the car loses $3,000 in value every year. For part B, I'm going to let t be 5. Remember, we wanted to know the value 5 years later. So if I let t be 5, I have v is equal to negative 3,000 times 5 plus 28,000. So I get a value of 13,000 when you do all the number crunching. If you look at this formula for v, notice if t is large enough, the value of the car is negative. So it's kind of like you've kept the car too long. You can't trade it in. Nobody wants it. Our second example, number 2. The ideal weight, W, of a 25-year-old male is a linear function of his height, h. Okay, that sentence is saying W equals mh plus b. That's what that first sentence says. Now, a certain 25-year-old male is 68 inches tall and weighs 150 pounds. A second 25-year-old male is 72 inches tall and weighs 174 pounds. Notice I've got two heights and two weights. I've got 2 points. Express the weight W of a 25-year-old male as a function of his height h. Simplify your answer and do not use mixed and reduction within your answer. Now, this sentence that says express and the first sentence, they're saying the same thing. They're telling you W equals mh plus b. So again, let me go back in case you missed it. The first sentence says W equals mh plus b. Again, I had two heights and weights. I've got an h1 W1, 68, 150, and I've got an h2 W2, 72, 174. So again, compare this to y equals mx plus b. xy is hw, okay, because the h is with the slope, so h comes first, h plays the role of x. So my h1 W1, 68, 150, my h2 W2 is 72, 174. Now again, I've tried to rig it to be nice. We're going to see whether or not I did a good job. Okay, my 2-point form using the h and w is w minus w1 is equal to w2 minus w1 over h2 minus h1 times h minus h1. Okay, remember, the w was the y, the h was the x. Plug in the numbers. So w minus 150 is equal to 174 minus 150 over 72 minus 68 times h minus 68. Notice it's the same format as the previous example, just that I have different numbers. Okay, let's do some arithmetic. Okay, this one there's unfortunately no 0. If I do 174 minus 150, I get 24. If I do 72 minus 68, I get 4. So I have w minus 150 equals 24 over 4 times h minus 68. Okay, 24 over 4 is 6. So w minus 150 is equal to 6h minus 68. Distribute 6. So w minus 150 is equal to 6h minus 408. Add the 150. So you get w is equal to 6h minus 258. There's your equation. Notice, if h is not big enough, you're going to have a person with a negative height. Excuse me, a negative weight. Okay. So sometimes when you're given these modeling problems, in real life you have to be told the restrictions that are on the variables. Like you'd have to be told that this is only valid for heights between this number and this number. So again, it's still 2-point form, just different numbers. Okay, number 3. It says find a linear function f that satisfies f of 3 equals 2 and f of 5 equals 9. So you want to find f of x equals something as your final answer. Now, I've never quite understood why, but students always swear up and down when they have one of these problems as a homework. They'll say, we never did one in class. We're doing one now. So this is a point, this is a point. So this is really 2-point form of a line. So our x1, y1, 3, negative 2. x2, y2 is 5, 9. Now we can go ahead and use the x's and y's. So 2-point form, y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x1. Plug in the numbers. Y minus negative 2 is equal to 9 minus negative 2 over 5 minus 3 times x minus 3. Okay, on the left, minus minus is plus. This becomes 11 over 2. So y plus 2 is equal to 11 over 2 times x minus 3. Remember, we don't want general form, so let's just go ahead and distribute the 11 halves. So I have y plus 2 is equal to 11 halves x minus 33 over 2. Okay, now subtract 2. So I have y is equal to 11 halves x minus 33 over 2 minus 2. Okay, 2 is 4 over 2, so I'm going to have 2 times 2 is 4. So I'm going to have, now don't forget the minus sign, so 2 times 2 is 4, so I'm going to have negative 4 minus 33 all over 2. So y is equal to 11 halves x minus 37 halves. Again, the 37 halves came from doing negative 33 over 2 minus 2. Okay, remember, 2 is 4 over 2. Now remember, you're supposed to find a linear function f, so now don't leave it like this. Write f of x equals 11 halves x minus 37 over 2. There's your linear function. Now if you're really feeling ambitious, or if you're just really bored out of your mind, plug in 3 for x and see if you get negative 2, because you're supposed to. That's what this function is supposed to do. Then plug in x is 5 and see if you get 9, because that's what's supposed to happen. So there's our first little group of word problems, the line word problems. That's the end of sections 1-3 and 1-4.